Okay, so here's a little video showing exactly how to do these problems on the test. So starting off with the first one, we have x squared minus 2x plus 3. We want to turn that into vertex form. Vertex form, of course, is HK notation. We know that h is equal to negative b over 2a. Okay, that's given to us. We've studied this before, which means that it is negative 2, right? Negative 2 over 2 times 1. In that sense, we should just 2 over 2, which is just equal to 1. So h must be equal to 1. What is k? K is just equal to f of h. Okay, in that sense, we put in 1 here and we find out what k is. So this is 1 minus 2 plus 3. So 1 minus 2 plus 3. So essentially saying, what is 1 minus 2? That is negative 1. Negative 1 plus 3 must be equal to 2. Okay, which means that k must be equal to 2. What is vertex form? Well, vertex form is the form of y must be equal to a times x minus h squared plus k. Okay, that is vertex form. So to put our equation, this equation, into vertex form, we have to put it into this. So in that being said, we are left with y must be equal to a times x minus 1 squared plus 2. Okay, so what is a? A is just the initial coefficient, right? The leading coefficient. And in this case, our a was 1. So therefore, this is just y must be equal to just x minus 1 squared plus 2. So there we go. That is the vertex form. What is the vertex? We already said that our vertex is 1, 2. Okay? That is the vertex. What is the x-intercept? Okay, what is the x-intercept? To find the x-intercepts, we have to make sure that our y is equal to 0. Okay? So set y equal to 0, and we're left with 0 is equal to x minus 1 squared plus 2, right? Which means that negative 2 must be equal to x minus 1 squared, okay? Which means that negative 2 square rooted must be equal to x minus 1, which means that x has to be, or this is plus or minus, x has to be plus or minus the square root of negative 2 plus 1, okay? And in that sense, we are basically done with finding out the x-intercepts of this problem. Okay, the y-intercept of the problem is just setting x equal to 0. So we are left with y must be equal to x minus 1 squared plus 2. Okay, we said that x is 0, so that goes away. We're left with negative 1 squared. Negative 1 squared is just equal to 1. 1 plus 2 must be equal to our y, which means that y must be equal to 3. So there we go. So in that sense, we have found everything we need to know, right? This plus or minus square root of negative 2 can also be expressed as plus or minus the square root of 2i plus 1. Okay? Okay, so with that being said, we are done. We have shown it in vertex form. We have shown its vertex. We have shown the x-intercept, and we have shown the y-intercept. So we are fully done. So I am going to erase everything we have done so far and move on to the next problem. Okay, so next problem. We want to change this into vertex form, show its vertex, show its x-intercept, show its y-intercept. So again, vertex form, h and k notation, h is equal to negative b over 2a. What is our negative b? Well, b is 6, so that's negative 6 over 2 times 3, okay? Which means that that is equal to negative 6 over 6, which is thus equal to negative 1, okay? So there we go. What is k? K is just equal to f of h, right? So putting in h into f, we are left with what? So that's 3 times negative 1 squared plus 6 times negative 1, right? That is just left us with 3 plus negative 6, okay? Which just simplifies to 3 minus 6, which ends up being negative 3, okay? Negative 3 must be equal to k. So there we go. So that is our vertex, right? Our vertex is negative 1 comma negative 3. That's our vertex. And in that sense, we are able to now show our vertex form. Our vertex form is y must be equal to a times x minus h squared plus k. Okay? Now, we know our h, we know our k. So therefore, in vertex form, we also know our a. Y must be equal to a. Our a, we saw that it is 3. So 3 times x minus h, which is negative 1, squared plus negative 3. There we go. That's vertex form. We have shown its vertex. Now we just need to find out the x-intercept and the y-intercepts. So I'm just going to quickly do the y-intercept first because it's faster. The y-intercept, to find it, we have to set x equal to 0, which means that this is just 1 squared times 3 plus negative 3, which means that when x is 0, y is 0. So, 0. Okay? Our y-intercept is at 0, 0. So, we are almost fully done. Now we just want to know what our x-intercepts are. So same thing, but in this case we are leaving our y's as, we have our y as 0. We set our y equal to 0. So that means that to solve this, we move this 3 over here, and we are left with 3 must be equal to 3 times x. I'm going to go up a little bit. X plus 1, right? Because negative times negative cancels, so we're left with x squared. Okay? In that sense, we're left with 3 over 3, which is just equal to 1. 1 must be equal to x plus 1 squared, right? Which means that I'm going to move this over here, which means that plus or minus the square root of 1 must be equal to x plus 1, okay? And of course, the square root of 1 is just 1, so that just means that the plus or minus 1 minus 1 must be equal to x, right? Which means that the first x-intercept has to be what? Our first x-intercept using our plus 1. 1 minus 1 must equal 0, okay? Which makes sense, right? Our x-intercept is located at 0, and where else is it located? Let's try negative 1. So negative 1 minus 1 must be equal to what? Negative 1 minus 1, right? Negative 2. So, negative 2. So those are the two x-intercepts that are located there. We are able to find out problem number 2 very easily, and we're done. We're done with problem 2. Okay, so continuing on. Now we want to go on, we finished problems 1 and problem 2. And we're going to go on to finding out problem number 3. Okay, so problem 3 says find the maximum or the minimum value for the function. Our function is 3 minus 4x x minus x squared. Okay, so that's our function. We want to find out the minimum or the maximum value. So first off, just by looking at it, we should be able to tell whether or not it is a minimum or a maximum. So based on this equation right here, we are able to tell because of this negative in front of the x squared, which is the leading coefficient, that this is going to be a maximum, because if we draw out the way that our graphs look like, our graph looks something like this, right? Okay, so our graph looks like this, which means that this is now our maximum, okay? Something up here. We want to find out that value. So let me erase this really quickly. Based on that information, we are now able to tell how do you find the maximum or minimum? Well, you know that even if it's a maximum or if it's a minimum, you know that the actual value itself is the vertex, which means it's just back to h and k notation. So essentially finding out what is h and what is k. We know that h is just equal to negative b over 2a. That is h. We know that k is just equal to f of h, right? So what is h, first of all? Well, we have negative b, which is negative 4, so negative 4, which is just equal to 4, over 2a, 2 times negative 1, right? In that sense, the negative 1s would cancel, and we're left with negative 4 over 2, which just equals negative 2, right? So our h is negative 2. In that sense, we are done with finding out our h. Now we just want to find out our k. So what is our k? Our k is f of h, okay? So looking at f of h, we are able to tell what is first off, what is f of h? So let me erase this for now. F of h, meaning 3 minus 4 times negative 2 minus negative 2 squared. Okay, so negative 2 squared ends up canceling out the negative, which means that we're just left with 4. Okay, so 4 minus negative and negative end up canceling. We're left with 4 plus 3, right? And now we can see that 4 minus 4 cancels, goes to 0, and we're just left with we're just left with f of h as equal to 3. So that's k. K is equal to 3. So there we go. We have found out what the maximum or minimum value of this function is. We know that it is negative 2, comma 3. All right. And we also know that this is a maximum. And if we put it into our calculators, hopefully you guys will be able to see this. But if we do this, then 3 minus 4x minus x squared, and we graph this, you can see up here that is a maximum, which is exactly what we expected because the initial coefficient is negative 1, which means that that is a maximum. We have a graph that looks something like this, right? Okay. So, continuing on from problem number 3, we are now left with part B. So what is part B? How do we do part B? Find the maximum or minimum value of this function. Well, we just want to make sure that we can do this. We know that our f of x is equal to 2x times x minus 4 plus 7, okay? So with that being said, just to find out what the maximum or minimum value is, we just need to put it in h and k notation. We know that h, again, negative b over 2a, f of h, right? This should be very obvious. We've been doing this over and over and over again. So, what is h, okay? Negative b over 2a. Well, this is not in a form that I can recognize what is negative b over 2a. So we have to put that into a form that we can recognize first. So, based on this, we should be able to recognize that 2x times x is 2x squared, okay? 2x squared. And 2x minus 4 is negative 8x. Okay, we're just distributing the 2x and then plus 7. Now, with that being said, we're able to find out what h is just because we now know that it's in a form that we can recognize. The form is negative b over 2a, and of course, that means that we have a negative 8, right? Negative 8 over 2a, which is 2 times 2 is 4, okay? We're left with h is equal to, the negatives end up canceling, 8 over 4. And of course, 8 divided by 4 is 2, right? 8 divided by 4 is 2. So now that we find out our h, now we have to look at our k. Our k value is what? F of h. Put in 2 here. Well, we can either put it in this first one or in the second one. So let's just do it, we can do it in the first one if we wanted to. So 2 times 2 times 2 minus 4 plus 7. Okay, so 2 times 2, well, that goes, that's equal to 4. 2 minus 4 is equal to negative 2 plus 7. Okay, so 4 minus, 4 times negative 2 must be equal to negative 8 plus 7. Right? And that's the same thing as 7 minus 8, which means that k must be equal to what? Negative 1, right? So then our h and k value is 2 comma negative 1. Now, we're able to see that again. Whether or not it's a minimum or a maximum, we have to look at our initial coefficient. Our leading coefficient in this case is a positive 2. So therefore, 2 comma 1 should be a minimum because we are expecting our graph to look something like that. Okay? And we can check it really quickly with our calculator. Doing y equals 2x times x minus 4 plus 7 gives us something that looks like this, okay? And we can see that that is what our graph was expecting to look like, right? Where the end values point up on both sides. So that is a minimum value. And of course, we can calculate our minimum by finding out what the minimum is. Putting in our left bound. Our left bound is there, and our right bound is there. And we can guess our minimum is here at 2, negative 1. So right now this is flipped, but you should be able to see that this is an x at 2 and a y at negative 1, which is exactly what we found right here. So, and that being said, we are done with this problem. Okay, so now we're going to go on to number 4. So first off, a soft drink vendor at a popular beach analyzes his sales records, finds that if he sells X cans of soda in one day, his profit is given by this equation. What is his maximum profit per day, and how many cans must he sell for maximum profit? So, first off, we want to know what is his maximum profit. The word maximum, okay, I'm going to highlight this. The word maximum should give you a good idea of what we're actually trying to do. So, this is maximum. Okay, this is also a quadratic equation, which means that all we have to do is just find the maximum of this equation. We know exactly how to find the maximum of this equation. That is just h, right, is equal to negative b over 2a, and k is equal to f of h, or in this case, p of h. So let's see, what do we get for h? Right? So h says negative b, so that means negative 3 over 2a, which means over 2 times the negative of 0.001. Okay? And this is squared, or not squared, my bad. 0.001. Okay, let me change the eraser to stroke. Okay, so there we go. We see that this negative cancels with this negative up here, and we're left with this number. I am going to use my calculator to figure out exactly what this number is so that we can start working on it. 3 divided by 2 divided by 0.001 gives us 1,500. Okay, using my calculator, I get 1,500. So this means that his maximum, that the x-coordinate of the maxima is 1500. How do we find out the y-coordinate? Meaning, how do we find out the k-value? We just put it into p, and we get this. So we get 1500 squared is that times 0.001 gives us this. So we have negative 2250 plus 3 times 1500 minus 1800. Okay, so negative 2250 plus 3 times 1500 minus 1800, and I get 450. Okay, so our x-coordinate is 1500, our y-coordinate is 450. Okay, so with that being said, this is exactly what we got right here. Okay, 450. With that being said, what is his maximum profit per day? We know that profit is P of X. P of X also means it's the Y, which means that his maximum profit per day in dollars is $450. And we know that how many cans must he sell for maximum profit? How many cans must he sell to get $450 a day? 1,500 cans, meaning 1,500 cans. There we go. That is question number 4. So I'm going to erase everything. All right, now we are going to describe end behaviors, okay? So end behavior of y is equal to negative x cubed minus 8x squared plus x minus 4. So first off, we just want to know the end behavior, which means we literally do not care about this. We want to know this. What does this tell us? Well, we know that the a coefficient is negative, which means that whatever we see, we can either see 2 different kinds of end behaviors. First of all, the first end behavior could look something like a quadratic, and the second end behavior could look something like a cubic. I'm going to erase this over here. It could look something like a cubic, okay? So those are the 2 kinds of end behaviors. Now, what's our first clue? Our first clue is that this is the degree of 3. So it's definitely not going to look like a quadratic. So I'm going to erase the quadratic. Okay? It's definitely not going to look like a quadratic. It's going to look like a cubic, right? Because odd functions look like cubics, and even functions look like quadratics. 3 is odd, therefore it looks like a cubic. And it's also a cubic because it's x cubed. Now, what else do we know? We know that a is negative, which means that if this is positive x cubed, negative x cubed looks something like this. Okay? Erase this. That's what negative x cubed looks like. So, with that being said, we are now able to describe our end behaviors. What are our end behaviors doing? What is this doing and what is this doing? Okay, so now, as x approaches positive infinity, meaning as x gets closer and closer to positive infinity, what is y doing? Well, y is going closer and closer to negative infinity, as we can see. Okay? What about as x gets closer and closer to negative infinity? Well, as x gets closer and closer to negative infinity, y is getting closer and closer to positive infinity. And there we go. That's it. That's the answer for number 5. What about number 6? Again, we're trying to describe the end behavior. Here, we have no idea what it's going to look like, right? Because this is a form that we don't recognize. We have to put it in a form that we can recognize. What is the degree and what is the a value, a coefficient? So, distribute our x's, right? This is just equal to negative x squared minus, plus 4x squared minus 4x. This is x cubed, okay? So negative x cubed plus 4x squared minus 4x, all right? This is a form that we can recognize. This is how we know what to do. We know exactly how to deal with this problem, okay? So with that being said, we can look at it. Well, we don't care about anything other than the end behavior, so the rest of it doesn't matter, okay? Now we have to look at the degree. Well, the degree is 3, so therefore it should look something like this, right? Okay, now we have to make sure that it looks like that by seeing if our a value is positive. In this case, our a value is also still negative, which means that it should look something like this. And we can erase this. All right? Now, we're done. We want to focus on this and this, right? What are its endpoints doing? So as x gets closer and closer to positive infinity, y is getting closer and closer to negative infinity. As x gets closer and closer to negative infinity, y gets closer and closer to positive infinity. And there we go. We're done with questions 5 and 6. Easy, right? Easy so far. Now, we're going to go with a polynomial, okay? So, here's how we're going to do it. If you think about it in terms of steps, I'm going to make this a little bigger. I'm going to draw my graph like this. Okay? First off, we want to see what are our zeros. Okay? So we have a 0 at 1, and we have a 0 at 2. So these are our zeros. These are our zeros, okay? So at 1 and at 2, those are our zeros. So let's say that at this location right here and at this location right here, we have zeros. Now, we want to see the multiplicity of those zeros. So first off, the multiplicity of the 1 is 2, because we look at the degree of that, and it is 2. So therefore, the multiplicity, our m value, or multiplicity value is 2. What about the multiplicity of our 2? Our multiplicity, our m value is 3. Okay? So far, so good? Now, we're almost done. What is the degree of this polynomial? Well, we know that if we add all the multiplicities together, we will be able to find out the degree of our polynomial. So, what is 2 plus 3? 5. Okay? 2 plus 3 is equal to 5. So therefore, we know that this degree is 5. Now, the degree is 5, meaning it's an odd degree. We want to know if it is a positive a value or a negative a value. Well, we know that our a value is located right here. There is no negative sign, so therefore it is a positive a value. So it should look, the end values, the endpoints should look something like this and like this, right? Because 5 is an odd, 5 is an odd number, therefore it should follow the fact that it should look something like a cubic. So now we just have to connect the dots, right? We have to make sure that we only cross the x-axis at these zeros. Okay, so we have to make sure we only cross the x-axis at these zeros. So we can see that 1 has a multiplicity of 2, so therefore it should look, if we zoom in really, really close, right? If we zoom in really, really far, we should be able to see that this should look something like a quadratic, right? And now continuing forward, we want to cross our x-axis at 2, which means we have a multiplicity of 3. So it should look something like this, and connect the dots. So you can see that this should be a multiplicity of 3, right? Something like that. And now this is our finished graph. Okay? This is our finished graph. But in order to earn full points, we just want to make sure that we understand where everything is. And so we need to make sure that we understand that we have a 0 point here at 1 comma 0. We have a 0 point at 2 comma 0. And we also want to find out what this is, okay? What is this y-intercept? How do we find out the y-intercept? Well, we have to set x equal to 0, and that's how we find out our y-intercept, okay? So, if x is equal to 0, that goes away, and that goes away, and we're left with -1 squared times -2 cubed, right? So -1 squared, of course, is just 1. -2 cubed is what? So -2 times -2 is 4. And times -2 is -8. Okay, so that means that our y value is -8. So at this location, it would be 0, comma, -8. And now we're done. We're fully done. That is the graph of this polynomial. That's all I'm asking you to do, okay? On the test, this is what I'm asking you to do. Now let's continue on to the next polynomial. So this polynomial, we have to make sure that, first off, we set up our graphs. We have to find out exactly what are our zeros. So we have a 0 at 1, and we have a 0 at 2. So those are our zeros. So 1 0 here, and 1 0 here, okay? Now, we have to make sure that this is in a form that we can understand. This right now is not a form that we can understand because we have 1 minus x, 2 minus x, right? So we have to make sure that it's in a form that we can understand. In order to do that, we have to check our multiplicities. So our multiplicity is 2, and our multiplicity is 3, which means that the multiplicity of 1, the 0 at 1, is m equals 2, and the multiplicity at 2 is m must equal 3. Okay? So, with that being said, the total degree, or degree, must be equal to 5, right? What is our a value? Our a value is positive for now, because we don't know anything else. Its a value is positive. But we have to make sure it's positive, because sometimes it's a hidden negative. Because in here, what happens if we square, for example, -x squared? -x squared just becomes x, okay? So that means that if we were to expand this out, we expand it out to 1 minus x times 1 minus x, 1 minus x times 1 minus x. And that being said, we have 1 minus x minus x minus x. Okay, so sorry about this. I made a big mistake at the very beginning. Over here, I did a multiplication where it was x times x. I accidentally put in -x squared, which in that case is wrong because, of course, -x times a -x is x squared, positive x squared. But from there on out, everything is fine, which gives you this long equation. You could simplify it, but in the end, it doesn't really matter because we only care about this, right? We only care about our a value. It turns out that our a value is actually negative, which means that our endpoints, right? Our endpoints usually looking like this, right? When our a value is positive and it's also a degree of 5, it actually ends up being that our endpoints don't look like this, they actually look like this. Okay? Of course, now with that being said, now we can just connect the dots. So we can only cross the x-axis on these 2 points, okay? So with that being said, we know that 1 has a multiplicity of 2, so if we go on connecting the dots, multiplicity of 2 right there, right? And now we know that 2 has a multiplicity of 3. Okay? So there we go. Connecting the dots, right? So we can see that zooming in this area, that looks like a cubic. Zooming in here, that looks like a square, which is exactly what we see, right? This is the multiplicity of 2. This is a multiplicity of 3. So therefore it's fine. It works really well. I'll go back to pencil. Okay, so we can see that we're basically done. Now we just have to mark what our multiplicities are, or sorry, what our zeros are, the locations of our zeros. So of course we have a 0 at 1, which means that this is not 0. This is 1 comma 0. This is a location of 2, so 2 comma 0. And finally, we want to find out what this location is, which of course we can find it very easily by just setting x equal to 0. If x is 0, that goes away, and we're left with 1 squared times 2 cubed. And of course we know that 1 squared is 1, 2 cubed is 8, which means that when x is 0, y is positive 8. So up here, positive 8. Okay? So there we go. This is the location of 0 comma 8. And that is how you would get whole points, right? On this graph. Now, another way you could do it just really fast without having to do the expansion yourself to save yourself some time, you could just look at this, right? You know that rule in algebra, what you're not supposed to do when you see something like x minus 1 squared? That rule in algebra where it's like this is not equal to x squared minus 1 squared, that is still true. But it does help us simplify some of the things, okay? If we were to do that way, if we were to do it this way, 1 minus x squared, okay? If we were to do it this way, this should be using bad math. Using bad math, we would get something like 1 squared minus x squared, right? 1 squared minus x squared. And of course, 1 squared is just 1, so negative x squared would be just x squared, right? The equivalent of that would be just x squared because the negative would cancel with the square. Okay, so again, using bad math, you could do the same thing with the other one. So 2 minus x cubed. With bad math, you would get 2 cubed minus x cubed, right? So with that being said, we can see that this and this ends up a result of negative x cubed, okay? And there we go. Since these two are being multiplied together, we multiply these two together. What is x squared times negative x cubed? Well, that is just negative x to the 5th, which is what we get at here. So, like I said, this is a very bad math example, so I wouldn't really recommend it. But it does save you some time if you don't want to do the expansion like I did all the way down. It saves you a lot of time, and it also kind of tests your understanding. But you obviously don't have to do it that way that I'm doing it. Now, if we were to do the bad math way, okay, the bad math way in this one, this expansion, we want to find out what is the initial coefficient, right? The leading coefficient and the leading term. We want to find out what's the leading term. What does it look like? Well, this is x cubed. The leading term here would look something like x squared. The leading term here looks like negative x, right? So in that sense, we have x cubed times x squared times negative x. Of course, multiplying these together, we get this is x to the 5th times negative x, which means that this is negative x to the 6th. Okay, so there we go. If we were to expand this right here, our leading term would be a negative x to the sixth. Okay, if we were to expand this, our leading term would be negative x to the sixth. So you don't have to do it the way that I just did it, okay? If you want to be very rigorous and if you want to exactly be like 100% sure that you're doing it correctly, expand this out, okay? Expand it out and figure out what your leading term is. With the bad math way, you can think of it like a shortcut. It's like a shortcut. This is negative x to the sixth, okay? If you don't understand the shortcut, don't do the shortcut. Only do the shortcut if you understand what I'm talking about. But if you don't understand what I'm talking about, don't try do the shortcut because you're going to get it wrong. Because it's still bad math. There's no way to prove it. It's just a little shortcut. It's a pattern. So, anyways, that's our leading term. So I'm going to put this leading term up here. X to the sixth, negative. And now we're going to do the same thing, right? To graph this. Well, first we have to draw our graph. What are our zeros? Well, we have a 0 at 0. Right? Because 0 cubed is 0 times 0, anything is 0. So we also have a 0 at 1. We also have a 0 at 2. Okay, so now we have to look at the multiplicities, right? What is the multiplicity of the 0 is cubic, right? So the m value would be 3. The multiplicity of the 1, 0, is 2. So our m value there would be 2. The multiplicity at 2 is 1. So our m value would be 1. Okay? So we have a 0 at 0. We have a 0 at 1. And we have a 0 at 2. Now, what are our end behaviors? What does it look like? Our end behavior is negative, meaning that whatever we do, if it's even or if it's odd, it's going to be flipped. What is our degree? Our degree is 6, right? 6, meaning that it is an even function, so it should look something similar to a quadratic, but this is an inverted quadratic because of the negative, so therefore our end behavior should start here. Okay? Now that our end behavior is starting right there, now we have to connect the dots. We can only cross the x-axis, this line, we can only cross this line at these zeros. If we cross it at any other 0, we did something wrong. We have to cross it at these zeros. So, connecting the dots, we have a multiplicity of 3. So it should look something like this, right? If we were to zoom in, that should look like a cubic. The 1 has a multiplicity of 2, so it should look something like this, okay? And the 2 has a multiplicity of 1, so it should look something like that, right? So if you were to zoom in on this location right here, it should look like a cubic. If you were to zoom in on this location right here, it should look like a square. And if you were to zoom in on this location right here, it should look linear. Okay, with that being said, we want to mark all the locations that we have. So of course, this location right there is 2, 0. This location is 1, 0. And this location is 0, 0. Okay? Now, we could say, what is our y-intercept? Meaning, if we set our x's equal to 0, what does our y get? Well, we can obviously see if we set our x is equal to 0, if we set the first term equal to 0, everything else becomes 0. So therefore, our y-intercept is 0, 0. So in that sense, we are done. If your graph looks something like this, with these locations marked, then you would get full points. Okay, now we are going to do number 8. So graph the following polynomial. So factor first, find 0, then graph. So first off, we need to factor to find the 0. Okay, to find its zeros. So what kinds of zeros do we have here? Well, what do I see? What of the numbers 6 and 3 have in common? Well, the numbers 6 and 3 have in common is the number 2. So the way that this would work is, what if we just do x cubed squared minus 2 times x cubed. plus 1, where x cubed is equal to our new x, right? So it should look something like this, where x squared minus 2x plus 1. Okay? Now with that being said, this is a square, right? A perfect square. So that means that we can just do x squared minus 1 to factor this out. Can we all agree on this? Sorry, not x squared, x minus 1 squared. Okay, x minus 1 squared is equal to x squared minus 2x plus 1, right, to factor this out. Now we did say that x cubed is equal to x, so therefore if we substitute in this x cubed into this x, we should get our final answer, which substituted becomes x cubed minus 1 squared. Now, with that being said, we have finally found our factored form of this polynomial right here. Now what we have to do, I'm going to erase everything now. What we have to do is, I'm going to rewrite this up here. So x cubed minus 1 squared. Okay? So now we are going to have to graph this polynomial. So what are the zeros of this? Well, we can set this equal to 0, for example, right? And of course, the square of 0 is 0, so that means that x cubed minus 1 is equal to 0, right? Because if you did this step, is x cubed minus 1 must equal the square root of 0, and 0 times 0 is the square root of 0, right? So there we go, 0. And now we're left with x cubed minus 1, and so that means that x cubed must be equal to positive 1. X cubed must be equal to 1, which means that x must be equal to the cube root of 1. Okay? The cube root of 1. Which, of course, in the end is just 1, right? It's just 1. So, with that being said, we can find out that this 0 right here is 1. So there's a 0 at 1. Now, what can we do? Well, we know that there's only one 0. The only 0 is at 1, which means there's only one real 0, which means that this 0 has a multiplicity of 2. So our m value should be 2, right? Now let's graph a polynomial and zoom in to our graph. So our 0 is at 1. Our m value is at 2. Sorry, got interrupted. Okay, so our m value is at 2, which means, well, now we have to graph. The degree is 6, which means that it should look like a quadratic. The a value is positive, which means that it looks like a positive quadratic. And now we know that our m value, our 0 is at 2. So we have to finally graph this, right? We have to graph this. Well, looks something like that. True. But we're not fully done, because this is a degree of 6. And we know that any polynomial with a degree of n has n amount of zeros. Okay? So there's no way that we have learned yet to find those zeros, but we do know that we have to graph at least 2 points, right? At least 2 points. So for this one, there's of course this first point. This first point has to be at 1, 0. Okay? And what about the second point? Well, the second point is our y-intercept, meaning what if we set x equal to 0? What do we get? If x is 0, this goes away, This goes away, and we're left with 1, which means that if x is 0, y has to be 1. Okay, so that means that our graph has to cross that y-axis at what? It has to cross the y-axis at 0, 1. So therefore, now we can connect the dots. And that is our graph. Okay, so that's what it would look like, right? Because we can only graph all the zeros, all the real zeros. We can't graph the imaginary zeros. We can also graph the y-intercept because that's a point that we know, and we can figure that out really easily by just setting x equal to 0. So when you get a situation that's similar to this, graph the y-intercept and graph your 0, okay? And then you'll get full points. So this would get you full points. So continuing on. Now we have to divide this polynomial by this polynomial. 2x to the 5th plus x cubed minus 2x squared. Let me just change this really quickly. Okay, 2x squared plus 3x minus 5 divided by x squared minus 3x plus 1. Okay, so we have our equation set up, right? We want to take a division. We want to divide this function. Let me see if I did this correctly. So yeah, 2x, x cubed, minus 2x squared, 3x, 5, yep. And then x minus 3x, 1. Okay, so first off, let's see. How do we get this? This is the same thing as 2x cubed. Okay, so 2x cubed. 2x cubed times x squared is equal to 2x to the 5th. 2x cubed times negative 3x is equal to negative 6x to the 4th. 2x cubed times 1 is just equal to 2x cubed. So plus 2x cubed. Subtract. This goes away. You're left with the result of I'm gonna write it down here. Okay, so negative 6x to the 4th plus 2x cubed minus 2x squared. Okay, so once I got that, once you get this, now what do you need to do? Well, negative 6x to the 4th. So looks like if we just do plus, 0 minus negative 6 is just 6. 0 minus negative 6 is 6. So that's positive. That's a mistake. Common mistake, but don't do that. Anyways, to get this, you need to do plus 6x to the 2nd power, of course. So that means multiplying it there. We're left with 6x to the 4th times negative 18x cubed. Okay, and then plus 6x squared. Okay, and of course subtract. These cancel, and you're left with 2. Oh, this is negative. My bad. This is negative right here. Oh, sorry. This is positive, but this is 1 minus 2x cubed, which is just x cubed. But 1 minus 2x cubed is just negative 1x cubed. Okay, so that is equal to negative x cubed minus 18x cubed is you are left with 17x cubed, and of course negative 2x squared minus 6x is just equal to 8 negative 8x squared. Okay, and we can of course we can always try and see if we can check our work and stuff. Negative 2 minus 6 gives us a negative 8. Okay, anyways, we're done with that. Of course, bring down the 5, minus 5. Oh, no, my bad. Bring down the 3x, bring down the 3x. So plus 3x, and then continue. So now what do we do? Well, this just plus 17x, right? Plus 17x. So 17x times x squared is equal to 17x cubed, right? 17x cubed. Now 17x times negative 3x, okay? I do not know that off the top of my head. So 17x times 3, that's 51. So that's minus 51x squared. And 17x times 1 is just plus 17x. Okay? So, do the subtraction. 17 cancel. You're left with negative 8x squared minus 51x, which is just x squared, which is just 51 minus 8, which gives you 43. 43x squared, okay? Sorry, 43x squared, and then, of course, 3 minus 17. 3 minus 17 is just the same thing as 14, so negative 14. So negative 14x. And now bring down the 5, so minus 5. Now last step, of course, to get this, we have to just add 43. Okay, so 43 times x squared is the same thing as 43x squared. 43 times negative 3x, so 43 times 3 is just equal to 129, so negative 129x. And 43 times 1 is just positive 43. Subtract, this cancels, and you're left with negative 14 minus negative 129 gives you 115. 115x, and negative 5 plus, minus, minus 43 is just 48, right? Plus 48. That was a bad one. Okay, so that is your remainder, okay? This is your remainder. So our new answer, of course, is right here. So some of you like to represent your remainder as r of, like a remainder of 2, remainder of 3. Some of you like to represent your remainder as the way that we usually do it, is putting this in a numerator and putting this in a denominator. Either way is okay. So for now, as long as you get here, you're fine. So for now, our final answer is 2x cubed plus 6x squared plus 17x plus 43, right? With a remainder of 115x plus 48. So 115x plus 48. Okay, so you can represent it that way, or you can represent your remainder as 115x plus 48 divided by x squared minus 3x plus 1. Okay, so you can represent your remainder in either way, either fashion, it's okay. Anyways, that's number 9. So I am going to fully erase this. I'm going to set this to area eraser. Okay, and now we're going to continue on to number 10. Number 10 should be the fastest, one of the fastest problems to solve using synthetic division, whether or not to determine this is a polynomial or this is a factor. So, okay, synthetic division just uses the coefficients of your polynomial. So, of course, we have a coefficient of 1. We have a coefficient here of negative 1. We have a coefficient of negative, 0. Why do we have a coefficient of 0? Because there is no x squared in this case. So that's a coefficient of 0. our coefficient for x is just -2, and our final coefficient is 6. Now, with that being said, we can set up our division like that, like so. And of course, our coefficient, like I said, here is 1, so we have the 1 on the outside. How do we do this? Well, just bring down the first number. The first number is going to be -1. -1 times 1 is equal to -1. -1, okay, so 0 minus -1, that is just equal to 1. 1 times 1 is equal to 2. -2 minus 2 sorry, -2 minus 2 is just -4. Okay, so now we get to see if this works out. So -4 times 1 is equal to 4. Okay, and of course 4 times, oh, my bad, here, 6, and we said this is -4. So 6 minus -4 is equal to 10. So, okay, so in the end we have a remainder of 10. So the resultant of this divided by this, we're left with -x squared plus x minus 4 with a remainder of 10. So does this fit into this? Is it a factor of this polynomial? It is not a factor. It's not a factor. So now we go on to the next one. Now this one has 27, -9, there is 0, there is 3, there is 0, and there is 3. And this is a -3. Okay? So of course, bring down the first number, we're left with 27. What is 27 times 3? 27 times 3 is just equal to 81. So that's -81. -9 minus -81 gives us a number of 72. Okay, so 72 times -3 gives us -216. 0 minus 216 minus -216 is just 216. So 216 times -3 is 648. Okay, continuing forward, we're left with 216 times -3 is 648. 3 minus 648, so 3 minus 648 is just equal to -645. Okay, so -645 times -3 gives us 1935. Okay, right, so 0 minus 1935 is just -1935. 1935 times -3 gives us a remainder of 5805 negative. Oh, wait, my bad. 1935. That times that is just, sorry. 5805. So 3 minus 5805 gives us a remainder of -5802. So, does this fit into this? It does not, because there is a remainder left over, right? This is the remainder, so therefore it is not a factor. Okay? So, continuing forward. So, for the 11, same thing. Test whether or not the c value is a 0 of the polynomial. Same question as number 10. The only difference is that now we're just testing whether or not 1, the number 1, is a 0 of the polynomial. Now, this is c1, c equals 1. Therefore, the 0 should be expressed as x minus 1, right? Because if it's expressed as x minus 1, Then if you put in 1 here, this becomes 0, which is exactly what we expected. This is what we want. So therefore, putting everything into coefficients, again, we're left with 1, because it's 1x cubed, minus 3, positive 3, and negative 1. Okay? And of course, we have a negative 1 here, because that is our coefficient right here. That's where this comes in. Remember, you see that this c is equal to 1? Don't put 1 here. C is equal to 1 is expressed as x minus 1 is equal to negative 1, right? So this is our coefficient here. So that means we're left with 1. 1 times negative 1, of course, is negative 1. Okay, so then that means negative 3 minus negative 1 is just equal to, sorry. Okay, so we are left with negative 3 minus negative 1 as negative 2. Okay, and of course now we have negative 2. Negative 2 times negative 1 is just equal to 2. Okay, so 3 minus 2 is equal to 1, which means that 1 times negative 1 is equal to negative 1. Therefore, negative 1 minus negative 1 is 0. So our remainder we can see is 0, and that's how we can prove, that's our test. The c value is a 0 for our polynomial, and now we have to calculate p of c. P of c, so essentially what happens if we put in 1 here? So that becomes 1 cubed is 1 minus 3 times 1 squared, which is just 3, plus 3 minus 1. These 1's cancel each other, these 3's cancel each other, therefore p of 1 is equal to 0. Okay? Same thing again, it's exactly what we expect from this problem, right? If you put in 1, you should get 0. So, continuing on to the second part of this problem, we are left with c of 1/2, which means that our coefficients for this first big one is 2, 7, 6, and negative 5. Okay? Now that we have those coefficients, our leading coefficient on the outside is not just 1/2, it's actually negative 1/2. Okay? So the reason it's negative 1/2 is because, again, we can express c equals 1/2 as x minus 1/2. Therefore, the coefficient is negative 1/2 in the front. So same thing, just like synthetic division, bring this down. So that's 2. 2 times 1, negative 1/2 is just equal to negative 1. Okay? So 7 minus negative 1 is equal to 8. Okay? Once you have 8, 8 times negative 1/2 is just equal to negative 4. 6 minus negative 4 is equal to 10. 10 times negative 1/2 is just equal to negative 5. Negative 5 minus negative 5 is equal to 0, so therefore there is no remainder, which means that c of 1/2 is 0. Same thing, if we put in 1/2 into here, we should get 0. Okay, so that's how you do number 11. So we're almost fully done with the problem. So lastly, the last 3 problems, okay? So the last 3 problems are as follows. So use the given zeros to find all the zeros of the polynomial function. So for part A, super easy, same thing as number 11. We just want to see if this is the, well, we know that this is a 0. We want to find the rest of the zeros. How do we do that? Well, again, do the division to find out the polynomial. This is part of our division section in our problem. So that's just 1, okay? 2, negative 9, and negative 18, okay? And of course, our coefficient that goes out here is just 2, because this is x minus 2. Sorry, x plus 2, right? X plus 2, which means that it's just positive 2. So there we go. So again, bring this down. We're left with 1 times 2 is 2, so this is 2. So 2 minus 2 is 0. 2 times 0 is 0. So negative 9 minus 0 is just negative 9. Negative 9 times 2 is negative 18. Negative 18 minus negative 18 is just 0. Okay, so what does that leave us? So we are left with x squared minus 9. Easy, right? So we know that x plus 2 is a 0, and we know that x squared minus 9 is also a 0, which means that one of our zeros has to be negative 2, and the other zeros can be 3, right? Because 3 squared is equal to 9, so 9 minus 9 is 0, or negative 3, which is negative 3 squared is still the same thing as 9. 9 minus 9 is 0, right? So in that sense, these are all of the zeros, which line up with our degree, right? These are all the possible zeros. All the real zeros we could have are only 3, and that's all we have. So next problem. 3, negative 8, negative 14, 31, 6, okay? Our first one is negative 2, which means that our coefficient on the outside is just 2. So again, bring this 3 down, we're left with 3. 3 times 2 is equal to 6, okay? So negative 8 minus 6, so negative 8 minus 6 is just equal to, negative 14. Okay, so negative 14. So negative 14 times 2 is equal to negative 28. Negative 14 minus 28 is just equal to positive 14. Again, 14 times 2 is equal to 28. 31 minus 28 is equal to 3. 3 times 2 is equal to 6. 6 minus 6 is equal to 0. So therefore, that is it, that we're done. Okay, so once we're done with this, we have to now actually find out what our new polynomial is. What's our new polynomial? Our new polynomial is 3x cubed minus 14x squared plus 14 plus 3. That's our new polynomial. We know that one of the zeros is x plus 2. We also know that the other zero is x minus 3. But we don't know the other two zeros. How do I know it's another two zeros? Because of this x to the fourth, right? That means that there's 4 possible real zeros. It doesn't mean that there has to be 4 real zeros. It just means that there's 4 possible real zeros. How do you find that out? Well, right now we just divided it by x plus 2 to get this polynomial, okay? Now we can just divide it again, right? X minus 3. So x minus 3 is this, divided by this. Again, coefficients, 3, negative 14, positive 14, and 3, divided by negative 3, okay? Bring down 3. 3 times negative 3, that's negative 6. Negative 14 minus negative 6 is just 8. Okay, so, negative 8, my bad. Negative 8 times negative 3 is equal to 24. Okay, positive 24. 14 minus 24. So 14 minus 24 is just equal to negative 10. Okay, and we are left with negative 10. We're left with 14, 3, 3. Oh, my bad. My bad. There's an error here. My bad. Okay. Let's just start from here. 3 times negative 3. 3 times negative 3 is equal to negative 9, right? So, negative 14. Negative 14 minus negative 9 is equal to negative 5. Okay, so negative 5 times negative 3 is equal to negative 15, or sorry, positive 15. 14 minus 15 is just equal to negative 1, which means that negative 1 times 3 must be equal to 3, because 3 minus 3 is equal to 0. So that means that our new polynomial, our resultant polynomial, is 3x squared minus 5x minus 1. What does this tell us? This tells us that these two are the zeros for this big polynomial. That's what we are expecting, okay? But it also tells us that if we can find these zeros, we can use them
to add to our total amount of zeros. We're expecting 2 zeros. From here, we're going to get 2 zeros. Unfortunately, we can't factor this, so we have to use our quadratic formula to find the zeros of this polynomial. So use quadratic formula. If you are curious as to what the zeros are in this one, I can put them really quickly in the calculator. Minus 5x minus 1. Okay, so once we graph this, we can go on to the calc function, calculate the 0. There's going to be 2 zeros. One of the zeros is going to be 1.84, okay? And the other 0 is going to be negative 0.18. So there's 2 zeros. One of the zeros is 1.84 and the other one is negative 0.18, which means that it's x minus 1.84, that's one of those zeros, and x plus 0.18. So this is a 0, this is a 0, this is a 0, this is a 0. Once we have all the zeros, we have 4 zeros, matches with our degree. So in that sense, we have found all the zeros. Now, for this one, find a polynomial function of a specific degree that satisfies the given conditions. Very easy. Okay, so zeros, negative 2, 0, 1, and 3, degree of 4. Okay, we have 4 zeros, and it's a degree of 4. Those are the only 2 conditions we have to satisfy. So x plus 2 gets rid of this one. X gets rid of this one. X minus 1 gets rid of this one. And x minus 3 gets rid of this one. This is a polynomial with degree of 4 with these zeros, right? You put in any of these numbers into this equation, you'll get a 0. Easy. Now, this second one, same thing, easy. Degree of 4. X plus 2, x minus 1, and x minus 3. Now, the only difference is between these 2 problems is that the coefficient of x cubed is 4. So the only way to actually figure out what this actually means is we have to expand it out. We have to make sure that it's expanded. So let's expand these 2 first. So x times x is x squared. X times negative 3 is minus x 3x. Okay. Negative 1 times x is just minus x. Negative 1 times 3 is plus 3. Okay. Now we have to expand that with x, multiply everything by x, and you're left with x cubed minus 3x squared minus x squared plus 3x. Okay. Now we have to multiply this by x plus 2. So, again, same thing. X times x is x to the 4th. Okay. X times negative 3x squared is negative 3x cubed. X times negative x squared is negative x cubed. X times x times 3x is plus 3x squared. Okay, and now we do the same thing with the 2's. So 2 times x cubed is just 2x cubed minus 6x squared minus 2x squared plus 6x. Okay, so that one's super long. Super long. Okay, so in that sense we are done. Now we just have to simplify this. So This is just x to the fourth. Negative 3x cubed. Let me just do this really quickly. Negative 3x cubed minus 1 gives you negative 4x plus 2, negative 2. So minus 2x cubed, okay? Minus 2x cubed minus, wait. So we're done with the x to the fourth, we're done with the cubes. Now we're keep going with the squares. So 3 minus 6 minus 2 gives us negative 5. So minus 5x squared. And now we're done with the 2's, and we're just left with the 6x. So plus 6x. So we're basically done. Now, we know that the coefficient of x cubed is 4. That's the only requirement. X cubed has to be 4. Well, how do we make x cubed 4? Well, what if we just multiply everything by 2? If we multiply everything by 2, I'm going to erase this now. We're left with 2x to the fourth minus 4x cubed minus 10x squared plus 12x. And that's it. We got all the zeros. We got the degree. We got the coefficient of x cubed is 4, but it's actually negative 4. So the only way we can solve this is if we just multiply it by a negative 2, right? So negative 2, so this becomes negative, this becomes positive, this becomes positive, this becomes negative here. So negative 1, yeah. And that is how we can solve this problem. Okay, so this entire thing was solved. Easy. We're done with that one. Now we're going to go on to number 14. So find the polynomial functions from its graph. So this is one of the easy ones again. So this one, the graph crosses at negative 1, it crosses at 1, and it crosses at 2. Okay, the multiplicity of this 0 is 1, the multiplicity here is 1, the multiplicity here is 1. So therefore, it's a degree of 3 function, so that we are expecting 3 zeros. Okay, so therefore, we should get x plus 1 times x minus 1 times x minus 2. This is a degree of 3. This is a function. We're done. Easy as that, right? You can expand this into, x cubed plus x squared plus, all that, but we're done. We're done. What about this one? Well, let's see. There's a 0 here at negative 1. There's a 0 here at 2. The multiplicity of the negative 1 is 1. The multiplicity of the negative 2 is 2. Therefore, it's a degree of 3 function. So the zeros are x plus 1, multiplicity of 1, times x minus 2, multiplicity of 2. And of course, the sum of the multiplicities equals the degree. It has to equal the degree. So therefore, 1 plus 2 is equal to 3. And so that is our function, and we're done. Okay?